Okay, we have this recording on. Now we want to go to MATLAB. I just updated all my licenses for MATLAB, so I should probably go around and update all the computers with the latest version. So, I think we finished chapter 2 last time. We should be on to chapter 3. Let's check Blackboard and check our schedule really quick. Should be in week 3 right now, I believe. So mpcc.blackboard.com, and we'll log in with our faculty stuff here, faculty and students. Sign in now, okay. And then I choose my programming problem solving. And then we're going to go to weekly assignments. Remember, when you go to weekly assignments, you should be clicking on the MATLAB shared document. And you should be putting in a tip, trick, or some kind of thing that you learned in MATLAB. So far, nobody's done that. And I'm going to be starting to grade here pretty soon. And once I start grading that, you won't have an opportunity to add anything to it until the next week again. So make sure that you get in and participate in that MATLAB shared document. Week 1 and week 2, let's see, what is week 1? Yeah, week 1 was just all the simple stuff at the beginning of chapter 2. And then week 2 was the stuff we just did last week. It's due today. That's that one. And now, week 3, we're moving on to chapter 3. So week 3's assignment is where we will get into chapter 3, and we will start submitting a little more complicated stuff. And we'll be doing multiple files. We have 1, 2, 3 files to submit for week 3's assignment. So, and also we will be using files that we need to download from Blackboard. For example, when you get to problem 4 in question 2 of the assignment, get down into problem 4, you're going to have to download this file mptemps.mat. You just click on it, and it'll take you to this option to open a file or save a file, and then you just save it, and it'll go to your downloads. But once you get it to your downloads, you need to open that up and get that over to into the directory that you're using in your MATLAB, because you're going to use this .mat file in your MATLAB, and we'll see a little bit of that today. So make sure that you're getting into Blackboard and doing the assignment and doing the shared document. I used to do a discussion every week where we had to submit discussion and stuff, but I found that to be not all that helpful. And so the shared document is what we use, but if we're not going to put stuff in on it, you're going to lose points in the class. So make sure you're doing that every week. I would do it first thing right after class every week if I was me, but so I didn't forget it. Of course, remember that if you miss any part of this this class time that we have together each week, I am recording them and posting them under the course videos. Now, let's see here. I have course videos from last year and this year. Let's see, did I mix them together? I don't know if I did or not. So let's see. I believe this one right here is from last week, 119. That would make sense, I think. No, I have 119 and 127. I have 127 in here twice. Why do I have it in here twice? I should delete one of these. There we go. Anyway, I have these videos in here. I've got 2 years worth of videos in here, so I need to organize them a little bit better so that I don't have them both at the same time. I'll go ahead and organize them. But if you click on any one of these, you're going to get a good understanding of what we're doing. And so make sure that you take advantage of that. I'll go clean them up after class today. So we're going to be doing chapter 3. Let's get into it. Let's open up our MATLAB. Remember that every class period you should be opening up an M file and doing all the work that we do in class. Anything that I type into the command window or into my editor window, you should be typing into an M file and saving it. And those are your notes, and then you should send those, you should upload those into your homework each week for your participation grade. So don't forget to start that right now, because the class starts right now. So chapter 3, oh sorry, we're not doing chapter, no, we're doing chapter 3. Let's see. Yes, we're doing chapter 3. We won't do everything in chapter 3, because as we get into section 3 let's see. As we get to about chapter 3.7, we do complex numbers, which we're not going to do a lot with at all. Complex numbers are not something we expect you to understand in mathematics for this class, so we don't get into it much. But then we will do 3.9 and I think some stuff in 3.8 as well, so that you can learn some of this stuff. We're going to skip a section in chapter 3, in other words. So anyway, let's get started on chapter 3. We've got some things to learn. Chapter 3 is mostly about a bunch of things that we can do mathematically with MATLAB using built-in functions that are already available in MATLAB. So let's start with a very simple one. Oh yeah, let's put my screen up here. Oh man, this projector's not working for some reason. Every week I leave it on and the projector takes forever to warm up. Hold on just a second, I need to grab something. Okay, so the screen is up and running. Go ahead. Screen is up and running, we're ready to go. First thing I'm going to do is erase a bunch of this stuff in my M file so I can add more stuff to it today. But, chapter 3. Let's start off with a simple one. X equals 9. I'm going to go ahead and suppress that output so that it doesn't print to the page here. So x equals 9 is the first variable that I'm going to enter into MATLAB. First little vector or whatever you want to call it. And then I'm going to use a built-in function. I'm going to say the square root of x. SQRT, and then you put your number in for x, and it tells me the answer is 3. So MATLAB can do square roots, and it's a little more powerful than that, but for now that will work. Let's do something a little more advanced. Let's say that instead of x equaling just a single number in its variable, let's give it several values. Let's make an array, 4, 9, 16, for example. All right? Oops. So this is our new x. We hit return. It's the row vector 4, 9, 16. And now we're going to take the square root. Let's assign this square root to a value as well. Let's say that b is going to equal the square root of now x. And it turns out that MATLAB can do that as well. We'll take the square root term by term of the matrix x. How about division? Let's do some very simple division. Let's take let's give the number, let's say y equals 15. Suppress the output. And let's do y divided by, we'll just use the slash symbol for division. And let's divide y by 4. Get 3.75. Okay, if you divide y by 4, you do get exactly 3.75. But what if I want to divide it and find out what the remainder is? So there is actually a function for that. If I want to do whole number division and find out the remainder, then I put the function remainder, or REM, and then I put the number that I'm going to divide, which is the 15, and I'm going to put in the number that I'm going to divide it by after a comma. So the remainder function requires two inputs: the function the number you're dividing and what you're dividing by. In this case, 4. So 15 and 4 tells you what the remainder would be. It turns out to be 3. 15 divided by 4 ends up being 3. Ends up being 3 with a remainder of 3, because 3 times 4 is 12, and 12 plus 3 is 15. And that can be very useful if you're trying to divide things up into groups and you want to know how many things are left over, for example, or whatever. Lots of different ways you can use the remainder function. Let's see what else. Another function. We're just going to be doing all kinds of random functions so that you can learn some basics here. Another function, though, is the size function. So d, we're going to make a little vector here. 1, 2, 3, 4, 5, 6. Just a row vector from 1 to 6. Very simple. And if I want to know what the size is, then I can say, what is the size of the row vector d? And what it tells me is two things. Okay? Well, what are those two things? It's the size of the vector's, it's the number of the vector's rows. This has one row, and it has 6 columns. So the size of this is a 1 by 6. 1 row, 6 columns. What if D has more than one row? So I put in a semicolon right here, turn this into a matrix with 2 rows, and then I do size of D again. It now has 2 rows and 3 columns. So it returns both of them. I can actually make a little, I can actually make a vector of this by saying that I'm going to put into a vector 2 variables, rows and columns, rows and columns. And then I can let that equal the size of D. Now this is something we've not done before. I'm actually assigning two different variables inside of a vector. So the vector is inside of the square brackets. There are two variables inside of this vector. One variable is called rows, the other one's called columns. And let's see what this gives us. It's going to tell me that rows equals 2 and columns equals 3. Because the size function returned two different answers, and usually we'll return them in a vector that has one row and two columns, then I can create a vector with one row and two columns and assign it to those variables within those rows and columns, which I call rows and columns. So that's just a nice little trick that you can learn really quickly here. Now, let's try this. G equals square root of the sine of x. Notice that I've got two sets of parentheses. The square root has its set of parentheses, and if I put my cursor around that parentheses, it shows me the other parentheses. So it underlines them both. And then the sine has parentheses. If I put my cursor around those, it will underline those two parentheses. Both functions need their own sets of parentheses. The sine is inside of the square root. So can I do this? Let's hit enter. Sure. It takes the square root of the sine of each of these numbers of x. The problem is that my previous vector x, wherever it is, where's my previous vector x? My previous vector x, 4, 9, and 16, each one of those numbers has a sign that is a negative number. And when you take the square root of a negative number, you get imaginary numbers. And so that's what these i's are, they're imaginary numbers. Let's do one that has, let's do something that has some positives. So let's do x equals, let's make a vector 0, and then pi divided by 2, and then pi. Let's take the sine of, no, let's do pi divided by 4. And then let's hit enter and let's go ahead and do the square root of the sine of x. And this one now gives us some positive values instead of imaginary values for square roots. So you can do functions within functions. You have to be sure, you have to make sure that it makes sense to take the square root of the sine of x. Some things it doesn't make sense to take the square root of them because the function will never return something that has a square root. And that does happen in MATLAB sometimes. You have to make sure that makes sense or MATLAB will either return an error or it will get stuck in some kind of loop that never ends and then you have to quit out of MATLAB. Let's take a look at some other things here. Let's see here. They don't go to a lot, they don't actually do a whole lot of other ones right now. But suffice it to say that it's not that hard to figure out a lot of math functions in MATLAB. Most of them are either the actual name of the function or an abbreviation of that name. But you can always use the help function to find out what something does. So if we do help, for example, and I want to know how to use the sine function, and I spell it S-I-N-E, it doesn't know what that is because MATLAB doesn't have a function S-I-N-E. I can go here to search the documentation, and then I can get some more help. If I search the documentation, it looks for the word sine inside the documentations, and then you can say, oh, here's a function of x. Here's a function in MATLAB. fx means it's a function in MATLAB. And I can click on this and I can learn all about the function sine in MATLAB. And I can learn that they use, instead of S-I-N-E, they use S-I-N. right? And then I can learn how to use it. They show all kinds of different ways to use it. They'll show all kinds of different examples. They'll show how to graph things with it. They'll show all kinds of things. And you can pretty much learn MATLAB just by using this help function to do what you need to do. If you think you know the name of the functions, then of course it's going to return that help, some of that help right here, not all of it. But you can always still go back to the reference in back here when you go back to this help page. This help documentation is very, very useful. Lots of detail. So don't forget to use the help function in MATLAB. Also, do not hesitate to use Google. You know, Google's a great place to learn about programming. It's one of my favorite places to learn about programming. So I go out here to actually let's type in MATLAB Easter eggs, for example. Just about every programming language has Easter eggs in it, so that you can type something into MATLAB and get something funny out. Let's look for something that's funny. Here's a nice one. This one is, what do you put in? Yeah, just image. I think this one you just put in image. Let's check it. Where's my MATLAB? Yep. So if you just type in the word image, it gives you this picture of this upside down boy, but it's not, that's not all that it is. It's actually more interesting than that. If we go back to here, we learn if you rotate the 53 bits of the double precision fraction component, you get all these different things that happen to the image. So it goes from boy to wolf to all kinds of things. And they show you how to do that. There's all kinds of weird things that people do in programs when they get bored. And the programmers that program MATLAB were no different. They did all kinds of stuff. Let's see. So apparently if you type in lala.m, nope, lala. Did I do that right? I didn't. Penny. Let's look at this one. This is just fun. We just like to play around with this just for fun. Let's see what we put in. What do we get when we put in penny? We gave us something. I don't know what. It's probably in my image file. Here's my image. So there it is. It gives us a three-dimensional image of the penny. And it's I don't know what that is, but it's kind of cool. And then if we do, let's do one more just for kicks and giggles. Shower, I don't remember what this one is. Nope, it didn't work. Some of these things get knocked out of MATLAB as time goes on. Anyway, lots of different things you can find in MATLAB if you just kind of play around with it, and it can be a lot of fun. But also when you're just trying to learn MATLAB, use Google to learn it. It's very useful. All right, let's take a look at yeah, let's look at some more math functions. If you go to page 68 in your textbook, there's a table of common math functions. There's the absolute value, the square root, the nth root, the sine, the remainder, the exponent, the log of x, the log base 10 of x. So all of these are some functions of MATLAB that you can use to do math. The ones that we would use in this class, we'd probably use the square root. I don't know if we'd ever use the nth root, but you can use the nth root to find like the cubed root or the fifth root or whatever else. For example, the nth root, and this has two arguments. The first argument being the number that you want to take the nth root of. I'm going to take 125. In fact, I'm going to take negative 125. And then I'm going to take the third root of it. So the cubed root of 125, which would be what is the number that when you multiply by itself 3 times gives you negative 125. Well, of course, that number is negative 5. Negative 5 times negative 5 is 25, times negative 5 is negative 125. So there are lots and lots and lots and lots of these types of functions. They give you a short list of them there, and you can find many more using help or Google or whatever else. So let's look at some. I don't actually like the example they give here because the example they give here involves all kinds of logarithms. But let's look at an example that is in our homework or similar, something similar to in our homework. And that is the equation for compound interest. So let's just look it up really quick. That's another good way to find math. Let's look up compound interest equation, because compound interest is something everyone should be interested in if they want to be a millionaire. If you want to be a millionaire, you need to learn how to earn compound interest instead of paying compound interest. We'll use this one, I guess. So this is the compound interest formula. The A is the amount that the amount of money that you will have in your account after so many years, however many years you calculate this for. The P is the initial amount that you put in the account. And then the R is the annual rate of interest on the account. The N is the number of times that the interest is compounded. And then the T is the number of years that the amount is borrowed for. Now, the reason I say that you need to learn how to earn this rather than pay this is the same formula that is used to calculate interest on a credit card, for example. Where if you put money into a bank, it's like you're getting paid the interest that you would pay on a credit card versus paying the interest on the credit card. You don't want to end up paying interest. Paying interest is like throwing your money away. When you buy cars using a loan, or you buy anything with a credit card, you end up paying interest. You end up throwing a lot of money away. The only time that you don't throw money away when you use interest is buying a house, and that's because the amount of money that you make keeping that house as it appreciates in value is usually about equal to the amount of interest you pay in buying the house. So it ends up evening out and you don't end up losing any money. However, if you'll take out multiple loans on your house so that you can buy things or add on to your house or anything like that, then you will end up paying more for the house than it's worth and throwing money away. So understanding interest is extremely important if you don't like throwing money away. If you don't care if you're throwing your money away, it doesn't matter. Go ahead and buy a car using a loan. If you take out a loan to buy a car, you will throw money away, guaranteed. It is just that you will pay twice as much for the car than it's worth. On average, most people will. Or not maybe twice as much, but a good 20-30% more than it's worth. And many people will pay as much as twice as much as it's worth because they don't understand interest. Understanding interest is everything in this life as far as money is concerned. And so this is an important thing to understand how to do, and you can do it doing MATLAB. You can do it with a calculator as well, but it's a pain in the butt with a calculator. It's not an easy formula. So what we want to do is figure out we want to figure out how much time it takes for us to earn a certain amount of money, or how much money we're going to make in a certain amount of time. You can use this equation just as it is to figure out how much money you're going to make in a certain amount of time. If you want to know how much time it's going to take to earn a certain amount of money, we're going to have to rearrange this equation, and we'll do that in a bit. But first of all, let's enter this equation into MATLAB. So we're going to start off with some variables some numbers we're going to plug in. We're going to have a P, an R, and an N, and a T. So let's go ahead and do that. Go to MATLAB. We'll make some variables. So my principal amount of money, let's say that I'm going to put in $1,000. That's a good starting point. So I'm going to start with $1,000 principal in my account. And then I'm going to have interest rate. Well, interest rates right now are not that great. And the interest rate is supposed to be as a percentage, so as a decimal point. And right now interest rates are pretty low, so I'm going to put it at 1%, although I think that's actually a little high. 0.01 is my interest rate. And then N will be the number of times that this is going to be compounded every year. And let's say that it's compounded monthly. That's not uncommon. Well, it's more common to be compounded quarterly, so let's do it 4 times a year. So we're going to compound this interest quarterly, and what that means is that's the number of times per year that they calculate the interest that you've earned, and then they put that interest in the account. And then the next time they put the interest in the account, they calculate the interest using the interest that's already in there as well as your principal. And that's where you really make money, is by earning interest on top of interest. And then the amount of time that I'm going to leave this in is, let's say, 30 years. So I put $1,000 in the account with an interest rate of 1%. We have 4 times, it's compounded 4 times per year, and it's going to be in there for 30 years. Okay? Let's see how much money we make. Those are my variables. I hit return. Those are all entered in now. Now I need to enter in my equation. My equation says that the amount in the account later on equals my principal times, now I put in parentheses, and I'm going to go inside my parentheses, and I'm going to go back to my thing here so I can remember what it looks like. Inside the parentheses I have a 1 plus R over N, so I'm going to put that in. So I have 1 plus R, and that's a little r over little n, right? Then I go outside my parentheses, and I'm going to raise this to a power, and I have 2 things that I'm raising it to, so I have to put parentheses there as well. And it's going to be to the n times t, the number of months, or the number of compound cycles times the time in years. And that is my equation. I go ahead and hit return, and I find out that I have made $349 in 30 years. So if I put in $1,000 at 1% interest, after 30 years I make $349. And you're like, oh crap, that sucks. 300 bucks in 30 years? Well, that's at 1% interest. Well, it's $1,349. I started with $1,000, so I made $349. Right? You say that stinks. Well, let's see what happens if you have a better average of interest. Like my average of interest over the past 10 years that I've been saving money for retirement has been much higher. It's been closer to 8% interest. And some people can get theirs as high as 10%. Let's say that we get to 10%. R equals, instead of 0.01, it's going to be 0.1. So I'm going to put in a new R, and then I'm going to calculate A again. A. Whoops. I'm going to calculate A by putting in the actual equation. There we go. So now I have a new R, and I'm putting in a new A, and now I've doubled my money. Does that make a difference? If you can double your investment, do you take that investment? Absolutely. Now it takes 30 years to do it, but no big deal. You put it away for 30 years, you double your investment. Still not that much money, but let's see what happens if we change the amount of money we start with. Here we've doubled our money. Let's see what happens if we change P. What happens if we change our principal? Let's change our principal to 100,000. Let's say you get in a car accident and the insurance settles for $100,000 because you break your leg and you have to go through the hospital for a few weeks, and they settle for $100,000. And so you get $100,000. Do you go out and buy a car, or do you put it in an IRA that earns 10% over 30 years? Well, let's decide. Well, it doubles your money, right? Now you've got $200,000. And that's with, oh, sorry, it doesn't double your money. Does anybody know what just happened here? Yeah, this is actually not double your money. This has made it $2 million. You've gone from 100,000 to 2 million, right?
How do you do that?
It's just interest. Compound interest does that.
No, where you just go up.
So when you just scroll up, you just go down, you just go up with the arrow, up arrow. So the number has doubled as far as the initial number, but the power has also increased dramatically, right? In this last one, when we went up to, let's see, when we went up from 1,000 to, oh, we went up to 10%. Is that what we did? Yeah, when we went up to 10%, we actually went up not by a double. We didn't double our money. We actually went from 1,000 to 20,000. So at 1% interest, we earned $349 in 30 years. At 10% interest with $1,000, we earned $9,000 in 30 years. So, or sorry, $19,000. So we 20 times our money. And then when we put in $100,000, we ended up with $20 million. So we 200 times our money. Okay? So the more money you put in with compound interest, it really increases how much you get out. It's not a linear thing at all. It is an exponential thing. And you can continually add to it. So if you continually add to it, it's even better. And that's a whole different equation. But this is the great thing about MATLAB. I put in the numbers, and I put in the equation, and I can just calculate again and again. I don't have to redo it every time. I can just say, oh, I want to change it to 10%. I want to change it to 3%. I want to change it to whatever. And then you just calculate again really quickly, right? It's very valuable. MATLAB's very good at doing this. And if you make it into an M file, it's even better at doing this, and we'll learn how to do that later. Excuse me. And this is one thing that you can do this with a lot of different programs. A lot of programs do this quite well. But MATLAB, you can create your own program within the program to do it. So that's really nice. So that's using let's see. So that's using MATLAB to do an exponential function where you have these numbers up in the exponent. Let's see if they've solved this. Let's see who has solved this compound interest. Time equation. So if you solve this formula for time in years that it takes to do something, takes to earn this money, then you get an equation that looks like this somewhere. Where is it? Here it is. Nope, that's not it either. Here it is. Then you get an equation that looks like they put numbers in it first. Why did they do that? They want it solved without the numbers in it. That's close enough. Okay, so what you get is an equation that looks like like this, where the 4 is an n, and the 1.55 is, let's see, that's your original amount, and the 1.075 is the 1 plus n over t. That's goofy, but it's good enough, I guess. I wish they wouldn't have put the numbers in. Let's see, where did they do it here? Well, I don't want to do the math in class because the math is beyond what we're supposed to be doing in this class. Let me see if I can find. Here it is. So here's the formula if you do it, if you're solving it for the number of years that it takes to make a certain amount of money. So it's years equals the log of the total minus the log of the principal divided by the log of 1 plus the rate. So if you're not sure what log means, log is just the opposite of an exponential. So if you have a number raised to a time in power, then the opposite of that would be the logarithm of it. And so it's maybe a little bit confusing to you, but MATLAB can do a logarithm. So we're going to go ahead and do that really quick. So we're going to put this formula in, years equals log total. We'll start with that. We'll make it as simple as we can here. Where's my... So let's say, I'll call it big T equals, now we're going to use the log of the total, which is the principal. No, log of the total, which is the accrued, or the total amount. There we go. And then we're going to subtract the log of the principal. So we subtract the log of the principal. And then we're going to take that whole thing and divide it by the log of 1 plus the rate. This whole thing, put parentheses around it, divide it by the log of the rate. Now yeah, there we go, log of R. Now it's actually going to be it's log of 1 plus the rate. There we go. It's 1 plus the rate. And it's the rate divided by little n in the end. There we go. And this should give us the time in years. And I think we actually have to divide this whole thing by n as well. Just do that. So this has everything in it that we should need, except we're missing, what are we missing? There we go. Okay, so with this A that we've got in here, according to all this formula here, it will take us 31 years. So it's not exact, we're missing something, it's probably the n in there. Let's do this again really quick and do r divided by n. Hit the return. Nope, that's not right either. So we use the previous one. So this one's pretty close. It's not exact, but it does give us the correct time. But now let's change this. Let's say that I want to be a millionaire. I want $1 million. I want to know how long it's going to take $1,000 to become $1 million if I have a particular rate. So my original amount, my principal is going to be 1,000 still. My amount that I want to finish at, A, is going to equal 1 million. And then I'm going to say that the rate is a rate proportional to today, not very big. R equals 0.1. So if our economy stays the way it is now for the foreseeable future, and I want to get $1 million from my $1,000, how long do I need to put it in there? Then I put in my formula, and it turns out, no, that's not right either. Yeah, I got to put in the correct formula. Which one is it? That's more like it. So 93 years if you start with just $1,000. But if you crank that up, you'll find out that it'll be a lot lower. If you crank up the amount that you start with your principal, for example, to equal 100,000, enter that in and then do your thing here. Dang it, that's not, oops, I didn't change anything. What did I figure? What did I not change here? I made some kind of mistake in my formula. But anyway, if you get the formula, if you have the formula correct from whatever source you're using for that formula, you can actually calculate how much that is. If for some reason I've got some mistake in mine, I don't have time to fix it because we got to move on. But this is where MATLAB can be quite useful in doing these formulas. Doing math, it's not easy. If you try to do this with a calculator, it gets really painful because there's just a lot of things to enter in. But in MATLAB, you just get the formula right, plug it in, and go for it. Just start plugging in variables. And we'll see a lot of examples of that. The reason I didn't want to show you the one in the book is because it's a little too, it's just too convoluted in its mathematics for this class. I didn't want to go through all that crap. So, let's move on to some other functions that we need to learn about. Rounding functions. MATLAB can round numbers. And it has, they're going to show us 4 different ways that it rounds numbers. The first one is very simple. It's just the round function. And you put in a number and you let it round it. And what it does is it rounds x to the nearest integer. So this is just like you would do in math. If you round the number 5.5, what would you get if you were doing normal math? You would get 6 because you go up from there, right? But if you did 5.4, if you round it to 5.4 instead of 5.5, it rounds down to 5. So that's just like normal that you're used to. However, if you use the function fix 5.5, what this one does is it cuts off the number at the nearest integer. So it just cuts off everything in the decimals and leaves whatever's left. So in this case, it's going to give you 5. It just cuts off the 0.5. So it's like rounding down to the nearest integer. And then you have the floor function. The floor function rounds down no matter what. So if I do the floor function of 5.5, for example, it will give me 5. But if I also do the floor function of negative 5.5, it will also round down. It will go down towards negative infinity and give me negative 6 instead of negative 5. Whereas if I do the fix function of negative 5.5, that one is actually going to round up to negative 5 because it's just going to cut off the 0.5 and not worry about going up or down. Okay? So, and then we have the ceiling function, which always rounds towards positive infinity. So the ceiling function, if I do 5.5, it always goes up to 6. And if I do the ceiling function of negative 5.5, it will round up to negative 5 because it's going to round towards the positive end. So those are some different rounding functions. How can that be useful? Well, let's say, for example, I've got bushels of wheat that I'm trying to calculate. And I say bushels is equal to number of pounds, and let's say I have 900 pounds of wheat. Okay? So I've got 900 pounds of wheat, and I'm going to divide this by the number of pounds in a bushel. Then I'm going to divide by the number of pounds per bushel. The number of pounds per bushel is 65 pounds, I think, something like that. And so I divide by 65 to get the number of bushels. But what it's going to give me is a fraction. I don't want 13.8 bushels. I want to know how many bushels I can make, how many whole bushels. So instead of doing bushels equals 900 by 65, I say the bushels equals the floor of 900 divided by 65, because that's going to round down whatever the number that is. So I can make 13 bushels of wheat, right? And there are lots of situations where you want that, where you don't want the fraction, you just want the whole number of things you can do. Because in practical real life, there's a lot of whole number things that we do. Okay? So that can be very useful.
What does the CO
The ceiling function always rounds up towards positive infinity, even if it's a negative number. It's the ceiling function. Yep. So, again, these are just all, we're just kind of throwing random things out there to show you the different abilities that MATLAB has. And you may or may not use these in this class a lot or a little or whatever else, but you will also find other functions on your own. And we will use other functions as we need them, and we'll discover other functions because we'll have to look for them. When we're trying to do some certain thing, and we'll use the help function, or we'll search Google, and we'll discover new functions, and we'll even make new functions of our own eventually. So we're just going to throw as many of these out here as we can before we start using them. So let's do some discrete mathematics. How many of you are familiar with discrete mathematics? You probably are and you don't know it. Discrete mathematics include things like the factorial. You ever use factorials? What is the factorial? The factorial of 5 is 5 times 4 times 3 times 2 times 1. Very useful when you're doing things like counting. When you're doing things like when you're doing number theories and series and other things like this. Very, very useful in statistics. Counting. Statistics is pretty much just counting. So the factorial, of course, when they're small numbers, it's very easy to do. The factorial when it's whole numbers is actually fairly easy to do. The factorial when it's fractions or decimals is very difficult to do. But factorials can get very difficult once they start getting big. Well, I mean, you just look at 5 factorial. 5 times 4 is 20, times 3 is 60, times 2 is 120. Not a big deal. Go to 10 factorial. Have any idea what 10 factorial is? 10 times 9 times 8 times 7 times 6 times 5. It's a huge number, but we can do it here. The function is fact. Nope, not, sorry. It's factorial. Different program I was thinking of. And you just throw in the number there. You hit enter. It'll tell you the factorial of 10 happens to be 3,628,800. Right? So, you can do math with those. You can divide factorial of 10 divided by factorial of something else. You can do all kinds of things with factorial in math. But you can also do many other things. For example, let's take just a random number and let's factor it. Factor, give me a number. 789. What are the factors of 789? Turns out that they are 3 and 263. That's beautiful. I picked a number that has 2 prime numbers as its factors. It's just randomness. Factoring a number, finding the factors of a number. So apparently 3 times 263 should be 789. And it is, right? So you ever want to factor a number? You ever been in a class where you need to factor a number? Your calculator doesn't do that. You find me, I don't know that there's a calculator that has a factoring function on it, because it's actually a fairly difficult thing to do. But this program can do it. So you want to factor any other random number, right? Factor it out. Well, here is 4,567. Apparently, Doesn't have a factor. Why is that? Well, because factor, the function factor only does a certain thing. It finds the prime factors. Okay? So if you don't have prime factors, then it's a prime number apparently. So let's ask. There's another function called isPrime. If we find a number that we think is a prime number, 4,567, you can ask MATLAB if it's a prime number, and it'll either give you a 1 or a 0. So apparently I picked a prime number as my second random number. That's really kind of random. That's crazy. I don't think I've ever done that. Let's try another factor. 4,563. What are the factors? So the prime factors of 4,563 are 3, 3, 3, 13, and 13. So 3 times 3 times 3 times 13 times 13 is equal to 4,563. That is a great, that's a great tool, that factoring tool. And also the isPrime tool. What if I want to know all the prime numbers less than a certain number? We have a function for that. The primes, all the prime numbers that are less than 500. Woohoo! Of course, we know that, I don't know why they don't put 1 as a prime number, but they should. But we know that 2 is a prime number, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59. You get up into the 60s and 70s, I really have to start thinking about it. Once you get up above 100, you really have to start thinking about it. But here they list all the prime numbers, 101, 103, 107, 109, 113, 127, going on and on and on, all the way up to 500. 499 is a prime number, right? Primes, and then put in the number that you want to know all the prime numbers less than that number. I put in primes 500, it gave me all the prime numbers that are less than the number 500.
So isPrime is if you want to know.
If a particular number is prime, like 4,567 is prime. In all of my time teaching this class, I have never picked a number for factor that is a prime number. That was pretty random. Kind of funny. Other things that you can do. You can change a decimal number into a fraction. It's the function is called RATS for rational number. But if you take a decimal number, let's take 45.67 for example, then it's going to make it into a rational number, make it into a fraction for you. Not terribly difficult to do. But here's another great one. The greatest common denominator. Don't you remember finding those in math class? You're going to hate that MATLAB can do this. Find the greatest common denominator between 45 and whatever, 21 or something, right? Finds the greatest common denominator for you. Or the least common multiple, LCM, can find you the least common multiple between two numbers. I'll just pick two at random. Least common multiple between 456 and 459 is 69,768. It's probably the multiple between those two. But anyway, not quite, I guess. So anyway, the point being is that you've got a lot of tools here. You can also do combinations and permutations. If you've ever dealt with permutations and combinations, it finds the number of possible ways that you can choose a certain combination of things from a group of, like if you have, for example, if you have cards in a deck. If you have the cards in a 52-card playing deck, and you want to know the possible number of ways that you can pick 4 of a kind out of the deck, you can use that to figure that out.
Do you have to put in a comma
Yes, when there are two things, when there are two arguments in a function, you have to put a comma between the arguments. That's different than when you're building arrays. So lots of different things that you can, lots of different functions that you can use mathematically. So for the n-choosec, which is the finding the number of combinations, if you have 100 people to choose from, and you want to know how many different possible groups you could make if you were choosing groups of 2, then you would use the n-choosec function with 100 comma 2. The total number of things you have to choose from, and the number that you're choosing out every time is your second number. That particular one gives you 19,900 different ways to choose groups of 2 out of a group of 100. No, that's 200. Groups of 2 out of 200. But anyway, that can be useful as well. Next, in page 76, they give you all the trigonometric functions, some of which we've used, the sine of x, the cosine of x. Then they also have the tangent and lots of others that we won't really use, but we do have lots of functions in MATLAB. But you must remember that trigonometric functions always use the radian measure unless you force them to use different measures. So if you want to use the sine of an angle in degrees, you don't use SIN, you use SIND. SIND will tell you the sine of the angle in degrees. The sine of 90 degrees, for example, is 1. But if I do the sine without the D on it of 90, it doesn't give me 1 because it's measuring in radians. So if you're not familiar with radians and you want to use degrees, use sine D and cosine D. And so on. So those are trigonometric functions. Lots and lots of functions that we've thrown at you. And we still have more to throw at you. What time is it? 1 o'clock. We've been going an hour. Let's take a little bit of a break and we'll come back and do some more functions. Learn some more functions for data analysis. And then we'll be done. So yeah, what time? So it's 1:09. Let's take maybe 6 minutes. Be back here at a quarter after. And we'll finish it up. All right. Now, more functions. Hope you're not too bored of just hearing function after function after function. But we've got more and more functions to do. So now we're going to learn about how to analyze some data using some of MATLAB's internal built-in math functions. So let's start off with a vector. Again, let's go back to a vector x. Actually, we've got one stored here. Here's a vector. That's not a very good one. Let's make a new vector x, and let's just let's use the one in the book, 153. Very simple vector, 3 elements, and we want to know what is the maximum value in x. What's the biggest value in x? So we hit max x. It tells us the maximum number in x is 5. If you have a huge vector, a huge matrix full of data, and that data came from somewhere else, it came from some instruments, or it came from another researcher or whatever else, this is an extremely valuable function. If you're looking for that maximum number in that file, then you can find it with one simple function. Also, you can figure out where it is in the vector. So if I do, if I make a vector a comma b, let's see. So if I make a vector a comma b and then let that equal max x, that tells the function max x that you want to know 2 things about where this maximum number is. First of all, you want to know what the maximum number is, and you also want to know where it is in the matrix. So we plug it in here, and it tells us that the maximum is 5. That's the first number it returns, but it also tells us it's the second element in the matrix. So go back here and you see that it is the second element in the matrix. Let's see, what else can we do with max x? Oh, you can find the maximum in each column of a matrix x. So if we have a new matrix that has 2 columns instead of 1, so here's our x, and instead of 153 only, we put in a second row that has 2, 4, 6 in it, maybe. 2, 4, 6, there we go. So now we have a matrix with 2 rows in it, and we want to know the maximum in each row. Then we can choose that. We do max. Let's see. If we do max just max x, this is going to give us some so it's going to give us a 3 returns here. It's going to tell us that there are 2 maximums, essentially two sorry, I lied. It's going to do it column by column by column. So in the first column, it's going to give us a maximum. In the second column, it's going to give us a maximum. In the third column, it's going to give us a maximum. So it's 2 in the first column, 5 in the second column, and 6 in the last column. And then if we want to split those up, we can do that as well. We can do the same thing we did before. I'm not doing this right. We can set up 2 variables, a comma b, so that it knows that we want 2 things back instead of just 1. And we can set that equal to max x. And then it'll tell us the maximum in each column, 2, 5, and 6, and it'll tell us which element it is in each column. The second element, the first element, the second element. So when you do it, when you have multiple rows and you use the maximum, it'll do it column by column, and it'll also tell you which element it is column by column. Okay, so then Let's do another one where we have two matrices. So let's do the matrix X that we already have, and let's do a matrix Y. And if you're following along, we're on page 81. The matrix Y is going to look like this. It's going to have the first row of 10, 2, and 4, and the second row of 1, 8, and 7. So it looks like that. And then we want to know the max of XY.
Quick question, do you have to put space in between the numbers or
Yeah, to make a matrix, you have to either put a comma between the numbers or a space between the numbers. And then you put a semicolon for each row, for a new row. Okay? So that's a space or a column for each, a space or a comma for each column, and a semicolon for each new row. So when you do this, though, this creates a whole new situation. What it does is it creates a new matrix that puts the maximum from each element of between X and Y in this new matrix. So let's see what happens when we hit return. So what it does is it compares X and Y in their first element. And it found out that 10 was the bigger number, so it puts in 10 here. And then it compares X and Y again, and it finds out that in the first column, second row, 2 was the bigger number from matrix X, and it puts in 2. So it creates a matrix with the maximums element by element from each matrix. So maximum can do different things depending on how you set it up, depending on how you tell MATLAB to use it. And then there's, of course, if there's a max, there's going to be a min. So if I put in min of X, it'll tell you the minimum number in each column of X. And if I do min of X and Y, X comma Y, it'll give me a matrix with all the minimum values from each matrix. And so on and so forth. Minimum XY works just like maximum XY, except it takes minimums instead of maximums. So, useful. But you can also find things like the average. Now in statistics, the average that we use, the thing that we call average in everyday life, is called the mean. So if I take the mean of X, it will take the mean of each column of X. Because X right now is a 2, remember X, this is X right here. X is first column 1 and 2, second column 5, fourth, third column 3 and 6. So what it's done is it's taken each column and added them together and divided by 2, because there's 2 elements in each column. It's taken the mean value or the average value of each column, and then it's created a new matrix. If X is just a single number equals 9, for example, the mean is not going to do much for it, is it? The mean of X, it's just one number, so the average of one number is just 9. So having multiple numbers is much more important. However, if X is a row vector, if X equals this row of numbers 2, 3, 5, 6, 8, and then we take the mean of X, then it takes the mean of all the numbers in that row and gives you just one answer. Now, are you familiar with the median in statistics? What is the median? So it just lines up the numbers from the smallest one to the biggest one, and it takes the number that's right in the middle. And if there are 2 numbers that are sharing the middle spot, if you have an even number of numbers, in other words, then it takes the average between those 2 numbers in the middle spot. Right? So if X is 2, 3, 5, 6, 8, what should be the median? Should be the one that's in the middle, which is 5, right? And it is. However, if X is not 2, 3, 5, 6, 8, if F is 2, 3, 5, 6, 8, 10, right? Then we take the median of X. It's going to choose 5 and 6 as the median and take the average between 5 and 6 and give us 5.5. So I can calculate the median. If you have a matrix like Y that's got multiple rows in it, then it's going to do it column by column by column. It will take the median of each column. What is the mode in statistics? Does anybody remember? The number that appears the most. So the mode of x, for example, apparently is 2. Why is the mode of x 2? Because there is no number that shows up the most. So it just picks the first number. However, if we change x to be 2, 3, 5, 6, 8, 10, 2, so that 2 shows up twice, and then we take the mode of x, it will definitely be 2. And if we make x equal 2, 3, 5, 6, 8, 6, 6, 6, right? And then we take the mode of x, 6 will be the answer. So it takes the most, the one that occurs the most in anything. And of course, if you take something that is like y, and it has multiple rows in it, so we have 1, 2, 3, 1, 2, 3, and 3, 2, 3, 4, and 3, 5, 6, for example. And we find the mode, well, let's not even do that. Let's do 1, 2, 3. This one will do it for us. Then we take the mode of y, because now y has 3 rows, 3 columns, a bunch of numbers in it. Take the mode of y, it's going to find the most common number in each row, and it turns out to be 3 in the first row, 2 in the second row, and 3 in the first column. 3 in the first column, 2 in the second column, and 3 in the third column. Column by column by column. We also have matrix operations where we can do things to a matrix all at once. For example, the sum of y. It takes the sum of the columns, column by column. 1 plus 3 plus 3, 2 plus 3 plus 2, 3 plus 3 plus 1. Turns out that they're all 7 for y, right? If we change y to be something slightly different, put in a 27 here, and a 35 here, and a 37 here, and a 33 here, and a 22 here, whatever else. You enter, return, take the sum of y, you get a very different answer. It just adds up column by column by column what the numbers are. If you just have a row vector, which we have one of somewhere in here, I don't know what x is anymore. What's that? Yeah, x is just a really long row vector. And you take the sum of x, it will tell you the answer is 54 after it adds up that entire row. So if it's just a row vector, it adds up the row. But if it has rows and columns, it adds up column by column by column. And then you can also do product. The product of x. Take all those numbers and multiply them together. The product of y, we'll do it column by column by column. Multiply the columns together and give you 3 answers. Excuse me. Let's see. So this one's an interesting one. This one's called the cumulative sum. C-U-M-S-U-M, cumulative sum. If you do the cumulative sum of x, first let's do x so we know what x is. The cumulative sum of x takes the first number and adds it to the second number and gives you the answer in the second spot. Takes the first number and just writes it in, and then takes the first and adds the second, then adds it in. And it takes that number 5 and adds the next number 5, 10. Then takes that 10 and adds the next number 6, and 16. Then takes the 16 and adds the next number. So it's a series of numbers. It's essentially a serial, what do they call it? Anyways, it's a series, it's a mathematical series. We also have the cumulative product, which is the geometric series, right? They call the other one the arithmetic series, right? But if you do the cumulative product, you get the geometric series, which is you multiply each number and get a new number, right? Cumulative product of x, and it takes the first number and writes it down, then it multiplies by the second number, and then it takes that answer and multiplies it by the third number, takes that answer, and keeps going, keeps going, keeps going. So that's the geometric series. Very useful in a lot of different counting and other things like that. And then, if you do it with a vector that has multiple rows, if you do the cumulative sum, then it does column by column by column once again, I believe. Let's check to make sure. Yep. So it does column by column by column, and the same thing with the cumulative product, column by column by column. Column by column. Now, I'm going to skip over a little part that involves some things that are math that we're not supposed to be dealing with. We're going to go to page 85, 3.5.4, sorting values. So we already have a vector x, and I want to sort x. Let's see what it does. First of all, let's figure out what x is. X is this thing, 2, 3, 5, 6, 8, 10, 2, 6, 6, 6. And I want to sort it. Sort x. What does it do? What it does is it sorts it in ascending order from lowest to highest number. Also a very useful feature when you've got big files of data that you need arranged in some way. But I can also sort it. And in this particular case, I have to write descend in single quotes to tell MATLAB that I want to sort it in backwards order or descending order. And I can also use the sort command with multiple row vectors. So if I sort y, it does it column by column by column. And I can also do sorting y in descending order. And you can also sort the rows instead of the columns. So if I go sort rows for y, it will sort it row by row by row instead of column by column by column. So, something very interesting is that the sort rows command will move the middle row into the top position. And if I don't want to do that, then I actually, let's see, if I don't want to switch the rows, I think that you have to just rebuild the vector after that. You won't have to worry about that. But, let's move on. So here's actually a pretty good example of where we would use something like this. There's actually another one. There's another one called sort rows n, so that you can sort sort your rows by depending on a certain column. So you're going to switch around your rows, but you're going to base it on the numbers in a single column. So this is called sort rows n. And what we're going to do is we're going to sort the rows of this matrix here. Inside of this, we're going to actually put on our matrix. No, actually we're not. We're going to put the matrix in first. So our matrix is going to be a set of times for skaters. Olympic speed skating times. They've got this on page 87. We have 5 skaters, so our first column is going to be a number of the skaters. So we're going to have 1 for our first skater, and then his time will be 41, they're saying 41.9. I'm just going to put in some random numbers here. Then my second skater will have a time of, let's say, 40.8. And then my third skater, every time I make a new row, I got to put in semicolon, of course. My third skater is got a time of 42 or whatever. So there's my times, my skater number and times for each skater. Each skater has a number and a time. And I don't want to necessarily sort each row, because if I sort each row, what it's going to do is it's going to rearrange the numbers here. So, so I don't want to sort each column, so I don't want to use the sort thing. But I do want to use the sort rows thing. But I don't want it to change the numbers around for the times around for different skaters, right? So I want to keep this thing so I want to keep each row separate. This one actually uses the sort rows command, uses the sort rows function. So what it's going to do is it's going to look for let's see, is that right? Nope. This is where I want to use the sort rows in. Because what sort rows does is it looks at the first column and it sorts all of the rows according to the first column. So if I use just sort rows, it's going to give me back the same vector. If I use sort rows for my answer, this is called answer, so I'll just say answer, then it's going to give me the same thing back because it sorted them according to these numbers, 1, 2, and 3. But if I want to sort it according to times, then I need to use the sort rows n and choose the second column. So I'm going to sort rows for my answer, and I'm going to choose the second column. And then it will, what did I do wrong? Sort rows. Oh, it's not, I don't actually use the sort rows n. It's just sort rows answered, comma 2. It's the same function, but I put a comma 2 in it. And then it is now arranged the rows in order of the times, from the lowest time to the highest time. So that is also a very useful function, how it's used. Okay. Goodness gracious. So many functions, so little time. Here is another function that's very useful called the size function. There's the size function, and then there's the length function, and then there's the number of elements function. So if I have a matrix Y, for example, and I want to know what size it is, I just put size Y, and it will tell me that it's a 3 by 3 matrix. It has 3 rows and 3 columns in Y. And it's always rows, columns. Rows first, columns second. Make sure that's correct. Yeah. Rows first and columns second. And then, let's see, length. So what length will tell you is just how many elements are in a matrix. Well, is that true? No. It'll tell you the largest dimension of a matrix. So, for example, my matrix back here called answer, if I look at, no, not answer. If I look at, let's look at X, for example. What is X? X has this it's one row and a whole bunch of columns. So if I do length of X, it'll tell me the longest dimension, which is going to be the number of columns. It turns out to be 10 columns, right? If I do the length of Y, it's a 3 by 3, so they're both the same value. And so it'll just return 3 because neither of them is the same, is different. But if I have a 2 by 3, if I have a matrix that looks like this, for matrix M equals equals 1, 2, 3, 4, 5, 6. It's a 2 by 3. Let's make it a 3 by. Let's make it a 4 by 2 actually. So this should have 4 rows and 2 columns. It does 4 rows and 2 columns. And then I find out the length of this one. It's going to tell me the longer of the two. The length of M is going to be 4 because it has 4 rows, 2 columns, 4 by 2. But then there's also the num elements. So it's NUMEL. Number of elements of M will tell you the total number of actual values that I've punched into there, which is 8. NumL in Y is 9 because it's a 3 by 3 matrix, and so on and so forth. So those are some functions for determining matrix size. They have this great example on page 89 through like 93. It's a pretty long one, where you upload a data file, which we can download data files from anywhere. Data files are just delineated number files, so it's essentially just a text file that has numbers in it that have spaces between the numbers and carriage returns, and maybe they have whatever else. But if you make a data file using just about any program, you can read it in MATLAB somehow, some way. MATLAB is able to import that, make it into a file that it understands, and then you can use it. And so here they tell us to go ahead and go to the weather service and get some data files. Let's take a look to see if it works. CDO dot in cdc dot noaa dot gov /co /co. Did not take me where I wanted to go. Took me to just the National Center for National Organization of Atmospherics, whatever it is. Anyway, I want some data files. Climactic Data Center. This is it. So global summary of the month. This will tell us the data. Data. KMZ file. There we go. Open with. MATLAB. Okay. So let's see if we get it. Oh, that's Cassini. Where is it? Oh, it's right here. So here's our data file. Where did it put it? Save this. And that's going to be messy. I need to import it through our importer here. Let's go back to here. I want to find a better data file. So here is this. Let's look at this one because this is a This is an Excel file, so we should be able to see what it is, see what it looks like. And go away. So here we have data that's delineated by cells. So we have latitude, longitude, elevation. We have these numbers in here that mean things. Who knows what they mean? So on and so forth. So in these things, you can see how the data is delineated, how it's separated by in different cells. And maybe we want all of it, maybe we want some of it, but MATLAB can deal with that, can read these things. CSV. This is not the same as we did before because they've changed their website, but that's okay. Let's go back to MATLAB. Anyway, you can download data files and then you can start using these functions. You can start using the max function to find the maximum temperature, for example, or you can start organizing. You can sort from the lowest temperature to highest temperature in the year. Or you can take averages, you can take means, you can do the median. So it's great for taking these huge sets of data from the weather centers or from anywhere else, flight times, purchases at Walmart, whatever. You can start to organize them, you can start to do statistics with them. Very useful and very powerful tools that you can do with this. And that's all that they do in this example, this very long example, is they upload a huge matrix and they start looking for maxims, they start rearranging things, they start organizing, sorting, doing some statistics, taking some averages, looking for medians, so on and so forth, just again and again and again. So those things aren't terribly difficult to use, but they're very useful, very powerful tools. In this next section, they teach us about variance and standard deviation, which I'm not going to teach because that's, again, beyond the scope of this class in mathematics. So we won't get into that, but suffice it to say that they're important for statistics when you want to do some heavy-duty statistics. But let's move on to something that is really interesting, and that is the formation of a random number. Page 100. So MATLAB, like any good program, has a random number generator called RAND. And if you just hit RAND, it actually just gives you a random number. If you hit RAND parentheses 5, it'll give you a whole bunch of random numbers. It'll give you 5 by 5 matrix filled with random numbers. You may ask, where do these random numbers come from? It's actually not technically random, but it's as random as a computer can get. What MATLAB does is it looks at the clock on the computer, and then it runs the number that's up on the clock, the time that shows up on the clock, and it runs it through an algorithm. And that algorithm changes from time to time. Every time it uses it, it goes through some different algorithms. And then it creates a random number from the time clock and algorithm that it's chosen that time around. So it's not completely random, but it's about as random as you can get with a computer. The only computers that do random numbers really any better than MATLAB are computers that do random number generation for cryptography. And the way that they do random numbers is they're usually connected to something that is a detector in the atmosphere, and they detect something in the atmosphere and use that detection value as their random number. And then they generate the random number. So it's coming from some event in the atmosphere, like temperature or wind speed or something like that. But anyway, random number generator in MATLAB can generate a single random number or a huge group of random numbers, but notice that the random numbers are always between 0 and 1, right? Always between 0 and 1. So if you want a bigger random number, you need to create it yourself. So let's do this. I'm going to do, this is going to be called random 10. So random numbers less than 10. And I'm going to do, this is going to equal random number generator. And I'm going to multiply by 10. So it's going to be 10 times my random number generator. And I'm going to make a 10 by 10, no, I'm going to make a 4 by 4 matrix full of numbers like this. So now all my random numbers are between 1 and 10, because I multiplied all those numbers that were between 0 and 1 by 10, right? But I could also make it even more complicated using some tools we use today. Not complicated, I could actually make it simpler. So I'm going to use my previous little function here, where random 10 is equal to 10 times the random number generator in a 4 by 4 matrix. But I'm now going to round everything down to the floor. So I'm going to take the floor of all these numbers. So I'm rounding everything down. So now it's going to be an integer between 1 and 10. Well, between 1 and 9, really, because it will never get to 10. So any number between 1 and 9, including 1 and 9. And they're all integers now, because I took the floor value. Or you could round them up. Instead of using floor function, I could use the ceiling function. Then everything will be now between 2 and 10. And you could do all kinds of things to this. I could take that everything in there, and I could do the ceiling function, and I could subtract something from it, or I could put a negative sign on it, make them all negative, or whatever. You can do whatever you want to do, right? So, random number generator. You can also make a random number. You can also make a random number matrix of any size that you want. So 3, 4 or 3, 5 will give you a 3 by 5 matrix of random numbers. They have some other ones that I'm not going to get into because, again, they take us into math that we don't want to get into. So they talk about Gaussian random numbers, which we're going to skip entirely. This is beyond the scope of this class. And now we're into this complex numbers, which we're going to skip entirely. And we're going to also skip computational limitations and move on to special values and miscellaneous functions, the last section of the book. So, special values. We have already used the special value of pi. Type in pi and you get 3.1416. If you use format long and you type in pi, you get 3.14159265358979793. You just get a longer version of pi, right? But we also have a value in MATLAB that comes up when you divide by 0. MATLAB knows that that is incalculable. It knows that it is infinity, so it just times out. If MATLAB actually tried to calculate that, it would get stuck forever in a causality loop, and it wouldn't work, and you have to shut it down. So it knows not to try. Also, when something is undefined as a number, for example, if you take the log of -20, no, it can do that again. It can do that because it understands imaginary numbers. Let's see. What is a undefined number for us here? There we go. So the log of I is an undefined function. Nope, sorry. It knows that one too. Dang, this is a smart computer. I'm trying to think of a function that is something that will give me this. Anyway, there are some instances where you would get the return NaN like this from MATLAB, which is not a number. I'm trying to think of one that is that MATLAB can't, that MATLAB knows is undefined, and I can't think of one. Maybe if I do infinity times 0, oops, that's an O, not a 0. There we go. So MATLAB does not understand this mathematics, infinity times 0. So it's not a number, because infinity is not a number. Let's see, what else do we have? Clock. Oh yeah, if you want to know the current time, hit clock. Doesn't really tell you much, does it? This is the number, these are the numbers that show up on the clock that tell the computer what time it is, and it uses these numbers to figure out time and date and everything else. But they don't mean much to us. If I want to know the date, I can do a similar thing here. Date. It actually knows the date. It actually will calculate the date for you, and that's kind of nice. But you can use this clock to actually to do random numbers or something like that. Time is not one. It doesn't have one. It just knows clock and date. EPS, you don't need to know anything about that. I never use that one. Then at the very end of the book, in the summary, they give a long list of all these things that we learned today. Commands and functions. There's a lot of them. I'll bet you there's close to 60 or 70 of these functions that we learned today. So, lots and lots of them. So, the homework is up and ready to go. In Blackboard, I will fix the videos on the YouTube site so that we have the videos labeled for this year and for last year properly. And then besides that, please remember to get on to Blackboard and enter your stuff into the shared document and get the homework done and all kinds of other things. So that is that for today. We will end recording unless you have a question. Any questions? Good to go? Okay. So we will end recording for today. If you have any questions for me, feel free to email me. Send your question by email or call me or whatever. It's a good idea to email and to send in maybe an image of what you're doing on MATLAB so I can see your file, see your code, and I can help you a little bit better. Besides that, have a great weekend, or a great week and then a great weekend, and we'll see you next week.